Well, this is my first attempt at doing the unit circle and trig circle since we didn't have time to finish it off in class. So I'm going to repeat what we did and introduce the unit circle for the first time. Pretend you haven't seen it, or if you haven't, well, this is your chance. If you've ever wondered where these numbers come from, root 3 over 2 is 0.866, root 2 over 2 is 0.707. And this is when you type in your calculator something like the sine of 45 degrees. And all of a sudden on your calculator, you hit the button and it comes out as root 2 over 2 if you have a fancy calculator, or 0.707 if you don't. How does the calculator know that the sine of 30 degrees is equal to 1/2? Well, obviously they were programmed, but where does it come from? So these numbers are actually numbers that come from a basic circle, and I'm going to explain to you where it comes from so that we could understand how to do sinusoidal functions in the future. So this is the basic topic. So on the next slide, I'm going to show you a circle that I've drawn, and I used a protractor. So basically I took this protractor, and I brought it over here. Let me just shrink the size a little bit. I made a circle. And if you look at the circle, the protractor, it starts off with 0 degrees on the right. It goes to 90 over here, and then goes to 180, and then to 270, and then back to 360. So we always read circles counterclockwise. So this idea of counterclockwise, which is this way, is the positive rotation. And if I go this way, it's just clockwise, and this is counter. This direction would be negative. So you have possibilities of going 0 degrees, minus 90, minus 180, minus 270, and then minus 360. Or you can go in the positive direction and go 0, 90, 180, and then negative 270. Positive 270, and then 360. So I'm going to remove the protractor, and I've marked 30 degrees, 45 degrees, and I've marked the 60 degrees on the protractor. So I'm just going to get rid of it so we could look at our circle. Maybe I'll just delete it. That's possible. Or make it really small. Go away. Okay, well, we just made it small. I've also used a ruler, which is in two tens, to draw this radius. So basically I've marked them off to start this off. And if you notice, when I marked this off, I call this the unit circle because it starts off with 0.1. This would be 0.2. This would be 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1.0. So 1.0, or 10 units, is why we call this the unit circle, because if this was 1 centimeter, or if this was 1 inch, or if this was 1 meter, we're separating each of the radius or radii into the segments so that we could be able to read coordinates if I want to read them off a graph. So this is 0.9, and of course this up here is 1.0. So if you just look at the graph, which is a circle. I said it's a graph because I've drawn it on a Cartesian plane. I didn't put the grid under, but hopefully you can see it. So basically I'm going to take a line and I'm going to mark where the 30 was in terms of the circle. Now, if you look at this 30 degrees and I ask you guys to read this coordinate, like if you had to read this off the Cartesian plane, I want you to look at what you read first. You would read the x's first, so it goes up around here. So I'll just make like a little dotted line in this So it's about here. So if you were having to read that, you would say that this is at a 0.8, in between 0.8 and 0.9. And so I will give it an estimate. In fact, because I know the number, it's going to be 0.866. And the y component is 0.5. This is 30 degrees. Right here is 30 degrees. Now, we said this is the x component and the y component. The x component is also known as cosine, and the y component is known as sine. So I'm just going to get rid of this word clock so I could write the word sine on top. So sine is what the y is. Now just hit your calculator button. Cosine of 30, you're going to get 0.866. And sine of 30, you're going to get 0.5. Now let's move it to the other angle that is very easy to spot, which is the 45 degrees. And if I bring down a line here, you notice that if I ask you to read the coordinates off of this graph on the circle, you're going to get 0.7, 0.7. Now, if you go on your calculator and you hit cosine of 45, you're going to get 0.7. And if you're going to do sine of 45, you're going to get 0.7. Now, let's do the 60. And if I just take a little line down to see where it goes, trying to make it as straight as I can, you'll notice that if you're reading your coordinates off the graph, at this point, it's between the 0.8 and the 0.9, therefore 0.866, and it comes down at the 0.5. You notice that this is the reverse of these. So the cosine, oh, actually, no, I reversed them by mistake. So I read the x first, the y first. I should have put the x first. So first you read this one, so 0.5, and then you read this one, which is a 0.866. Okay, sorry about that confusion, but basically this is the coordinate that's reversed of this. Now these are remarkable triangles. These are the ones we memorize, the 30, the 45, and the 60. And if you're looking for coordinates, that's basically where they're getting these numbers from. These are triangles that have a radius of 1 unit. They have all have this radius of 1 unit, so there's your hypotenuse, and you have the distance opposite and you have the distance adjacent. So this is your opposite, this is your adjacent. So that's how we know cosine and sine. Now, the easiest one to do is the 0 degrees. If you look at the coordinates here, well, what is this length? This is 1. So the coordinates right here, and I'll do this one in blue, will be 1, 0. So up here, the coordinates would be 0, 1. Obviously on this side, you're in the negative section. So your coordinates will be negative 1, 0. And down here, you're going to be 0, negative 1. So that's basically how they work. Are there other coordinates over here? Yes, but we don't memorize them. Unfortunately, we have to look those up. I mean, you could sit there and try to figure it out, but we only memorize the remarkable ones, which is the 30, the 45, the 60, the 0, the 90, and all the other basic ones, which is at the axis. Now, if you look at your circle, on the other side of the circle, you're going to have the same angle. So this would have represented the 60, this would have represented the 45, and this one would represent the 30. So at the same exact spot, on the other side, you're going to have the exact same coordinates, except the only difference is that if you have to remember the coordinates, you just have to remember that in this quadrant, the x's are negative and the y's are positive. So whatever you had here, you're going to have here, except this time, you're going to have them with specific signs. So we're going to do the signs. So this is going to be negative 0.866, 0.5. This one's going to be negative 0.7 comma 0.7. And this one's going to be negative 0.5 comma 0.866. Of course, when I'm talking about the 30, I'm talking about 30 from the horizontal. We're always going to be measuring from the horizontal axis. And on the other side, on the bottom, well, you're going to have the same thing. You're going to have 30 degrees. You're going to have the 45 in the middle, and then you're going to have the 60 degrees from the horizontal. And then you're going to have the same thing on this side. You're going to have the 45, and you're going to have the 30 from the horizontal. As long as you remember that all of these coordinates over here, so this one is going to be the same as this one. I don't think I drew it properly. This one is going to be the same as this one. In fact, I'll make all of the 45s red, and then I'll make the 60s in green. So you understand that all the colors are coordinated with the same values. So of course, down in this third quadrant, this one is going to be negative 0.866 comma negative 0.5, whereas the 45 is going to be negative, let's get rid of that little protractor here in the bottom. It's going to be negative 0.7 comma negative 0.7. And this one's going to be, the 60 is going to be negative 0.5 comma negative 0.866. Of course, on this side, the positive is the x. So for the 30 degrees, it's going to be the same as this, but it's going to be 0.866 and then negative 0.5. For the red one, it's going to be, which is the 45, positive 0.7 and negative 0.7. And of course, down here, it's going to be positive 0.5 and negative 0.866. So that's basically how you get to know all the coordinates of the circle. This is how the calculator knows cosine of 30 is that, and sine of 30 is that. Now, I also want to mention that this is a Pythagorean triangle. So if you wanted to highlight this, let me see if I can just highlight to show you what I'm talking about. This whole triangle right here is Pythagorean triangle. And if you were to do x squared, so all of this, if I call it, I'll do it in black. This is x squared and this is y squared. Well, x squared plus y squared equals c squared, or the hypotenuse. So if you were to take the distance from here to here and square it, plus the distance from here to here and square it, you would get 1. So all we have to do is prove that on the other side. So it's the idea that x squared plus y squared equals 1. That's the unit circle. And in the unit circle, let's say we took the 0.866 and we square it plus the 0.5 squared, we're going to get 1. Of course, they're not precise with decimals. We'll soon look at the fractions of these. So in the first screen, I said that this is root 3 over 2. So root 3 over 2 squared plus 1 over 2 squared is equal to 1. So let's just look at that. Root 3 over root 3. Root 3 times root 3 is 9. Root 9, which is 3. So this is 3 over 4. Plus 1 half plus 1 half times 1 half is 1 over 4. And that makes 4 over 4, which is indeed 1. So this proves that this is how the unit circle works. And that's basically where the numbers come from. Okay, hopefully you guys understood that. I'm going to move on to the next screen. And make that circle again. But this time, I'm going to remind you guys that we're going to have to start looking at the fractions of those what do we call them? Decimals that we looked at. We want to be more precise using the fractions. And everybody tries to memorize the unit circle, but there's a very simple trick for memorizing it. But it's mostly about understanding. So when you draw your circle, you always want to make your 3 lines. And so I'm going to just start this off with the 30. You want to put the 45, and then you want to put the 60. And this is really simple because there's a really easy trick to memorize how to do this. Well, first of all, you know that all of your corners are going to be 1, 0, -1, 0, 0, -1, and of course 0 and 1. But look here. What you can do here as a very simple trick is the following. I've only memorized one thing. In my life, I memorized that the sine of 30 is equal to a half. So once I've memorized that, I place it right here. This is the 30. This one would be the 45, and this would be the 60. So I say, okay, so there's my cosine and sine. So remember, cosine is your x, and sine is your y. So if I know that the sine of 30 is a half, this is the trick I do. I say, okay, let me see how many things I know on this test. Okay, or maybe things I don't know. Well, I don't know one thing. I don't know a second thing. I don't know a third thing. Let me count that again. I don't know this. I don't know that. I don't know this. Oh, but I have the top number. Maybe I'll get half marks. So I put everything under 2. Somewhere, remember, there's a bunch of square roots. Let me just put them everywhere. And there's my answer. So these are all my fractions. And then I just have to repeat the same fraction on this side. So basically, whatever you have on one side, you're going to put on the other. All you're going to do is change the numbers, negatives to positives. So for instance, again, for the first one, here, it's going to be -1/2 and √3/2. Now, if you notice the square of 1, the square root of 1 is still 1, so it doesn't really matter. And then this one is going to be -√2/2 and √2/2. And of course, this one is going to be -√3/2 and 1/2. And ta-da, you've got your unit circle. And then of course, you do them on the bottom. And you do the same fractions, except this time you're going to do negative, and here you're going to do positive, negative. Oops. You get the idea. And voila, there's your unit circle. Hopefully you'll understand where these come from, or you understood. And the next lesson will be on how to divide the unit circle when we're talking about radians. See you next time.